you drop a dumbbell on a soap dispenser, soap should shoot out. But the question is, how far? Welcome back to Engineered Bets. Today's line is 7.9 feet, which is slightly longer than Yao Ming is tall, and it's your job to predict whether the soap will travel further or less far than this calculated line. How on earth was the line set? Well, using the dumbbell for scale, it was dropped from about 1.3 feet above the dispenser. That potential energy was then converted into kinetic energy to determine the velocity of the dumbbell at impact, assuming no losses. Graphing the equations for each, and you see that 1.3 feet of gravitational potential energy for the dumbbell is equivalent to the dumbbell traveling at about 9.15 feet per second, meaning that will be the velocity at impact. Next, a soap dispenser is just a simple hydraulic system that uses two one-way valves to control the flow. Placing a ball inside a syringe allows you to easily see how a one-way valve works. When you pull up on the syringe, the suction lifts the ball slightly and liquid can enter the chamber. But pushing down on the syringe forces the ball to block the hole, thus preventing liquid from leaving. If I drill a hole in the syringe and by some miracle make a good enough seal using a hot glue gun, now you can see exactly how the dispenser works. Pulling on the syringe still allows liquid to get sucked in, but also pulls on the top valve, keeping that valve closed. Then pushing on the syringe once again blocks liquid from leaving the bottom valve, but opens the top valve, allowing liquid to exit out the top. Now, if you place a spring in the syringe to automatically return the piston to the top, you've got a semi-successful pump mechanism, as you can see here. Anyway, assuming the soap is incompressible, whatever volume of soap is pushed down by the piston will leave the nozzle in the same period of time. Since the piston's diameter is 4 times larger than the nozzle diameter, the cross-sectional area is 16 times greater, meaning the exit velocity of the soap out of the dispenser should be 16 times greater than that of the piston. And we'll assume the dumbbell has so much momentum that the piston will just move at the speed of the dumbbell at impact, which was calculated earlier to be 9.15 feet per second. That means the soap should be launched out of the dispenser at 146.5 feet per second. Based on the geometry of the dispenser, the soap will be launched from about 0.6 feet off the ground and 4 degrees downward. With this angle, you can split the initial launch velocity up into its vertical and horizontal components, and then we'll use kinematics to get our final answer. The acceleration in the vertical direction is a constant due to gravity, while there's zero acceleration horizontally. Since the acceleration is just how the velocity of the soap changes with time, you can integrate to get the shape of the velocity graph, and then use the initial velocity to fully define the function at all points in time. Likewise, you can do the same for the horizontal direction, which becomes a constant since there's zero acceleration, and that constant is just the initial horizontal velocity. This whole integration is a bit overkill for this type of simple example, but it's worth it in my opinion to get comfortable with it for the future. Anyway, since the velocity is just how the position changes with time, you can integrate again to get the shape of the position graph and use the initial height to fully define the vertical position of the soap at all points in time. Lastly, of course, do the exact same, but now with the horizontal position. Now going back to the vertical position graph, you can see that the soap will hit the floor 0.54 seconds after launch, and if the soap travels in the air for 0.54 seconds, it will reach a horizontal distance of 7.9 feet. And that's how the line was set. Now that you know, pause to think how reality will vary from this simple model and lock in your guess in the comments. And now it's time to see what actually happened. Well, as you can see, the soap dispenser definitely broke, but the soap was launched. One patch of soap landed around 3.5 feet, followed by more at around 5 feet, then a few more scattered drops, and the furthest point being at 97.5 inches or 8.1 feet, meaning the over has hit. Congrats to those who got it right. Personally, I took the under, so I got it wrong. Let me know in the comments which factor you think contributed the most to it being over. Also, just so you know, I lock in the methodology for the prediction before doing the experiment, and then just plug in any missing measured values later to get the line, regardless of how close or how far off that line is. Thanks for watching to the end, and I'll see you next time.